Hello everyone. This class let's learn conditional probability. Sometimes conditional information is known as assumed about the outcome of an experiment. This conditional information may have an effect on the probabilities of events. The new probability of an event E, assuming that event F occur, is denoted by the P of E given F. So this small bar we pronounce given, and is called the conditional probability that E will occur given that F will occur. Conditional probabilities are calculated using either the reduced sample space method or conditional probability formula. So P of E given F has two formulas. Let's see the first formula. Okay. Let's see the example, then let's see the formulas. Examples: a fair coin is flipped twice. So the sample space will give us, first, I'm going to flip a heads, and then second one is a heads. Or the first time is heads, second time is tail. Or tails, head. Or first time tails, second time tails. So the sample space can only have four outcomes. The event E is heads, 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 tail, tail, heads. The event F is head, tails, tails, head, tails, tail. So inside of the E and the F, you see we have three outcomes. Okay, let's continue to see G. G is H or heads, heads, tails, tails. J, event J has two outcomes. They are heads, tails, tails, head. Let's find what is P of E. So P of E. Okay, what is a sample space? Oh, we have learned P of E equals N of E, all divided by N of the sample space. We have learned this before. That equals E, how many elements? We have 3. So let's put 3 on the top. Sample space has 4. So P of E is 4. How about P of F? We have learned the formula P of F equals N of E over N of S. Oh, sorry, not E. This is F. Divided by the number of the sample space. So we are having 3 over 4. And how about P of G? It is N of G over N of S, or we say cardinality. Okay, how about N of G? So how many elements? We have 2 elements. The sample space has 4, and we simplify the top and bottom. We're having 1/2. What is P of J? P of J is N of J over N of S. N of J is 2, N of S is 4. It is 1/2. Let's see, find P of E given F using the reduced sample space and conditional probability. Let's see the reduced sample space formula. P of A given B. Say equal likely sample space. P of A given B equals N of A and B over N of B. The top is number of the outcomes in A and B. The bottom is number of outcomes in B. Okay. Another formula we call the conditional probability formula. The same thing. So this part, they are the same. P of A given B equals P of A and B divided by P of B. So the top and bottom, they are probabilities. So they are percentage, for example, 88% over 80%, for example. And this one is numbers. Sorry, for example, number of n numbers of m. Okay, let's see next part. Find the following conditional probabilities using reduced sample space. I should bring the pictures here because here I don't have E and G and J and F. So it is a page here. How to move it to the question there. So let's cross out all of these. What am I looking for? I'm looking for the question is P of F and E. Okay, we have learned two formulas, and this one we are using reduced sample space because you see I can count how many numbers in my event and how many numbers in my sample space. Okay, the formula is n of F and E, all divided by n of E. Let's see the number that is the F and E. So where is the F? Oh, here is F. So F and E, the element both in F and E, they are HT. TH, we have two elements. So on the top, we are having 2. The bottom, N of E, how many elements in the E? We have 3. So P, sorry, I copied the wrong question. This is given, the bar. Let me double check my question is P of F given E. Let me go back, check if I have copied everything correct. Yes, this is P of F given E. Next example, I don't want to go and see. Let me see. So if let's solve the question horizontally. P of E given G. Okay, P of E given G. So let's do the question horizontally. Looking for P of E given G. The formula using the reduced sample space, it is N of E and G, all divided by N of G. The denominator is the G, N of G. So what is E? N of E and G. It's clear here. So where is the E and G? Here and here. So HH, and that's all, because we have HT, TH in E, but we don't have HT and TH in G. So let's put 1. This is only one element, both in E and G, all divided by G, which is 2. Okay, how about next one? Let's solve them horizontally. Next one is P of G given E. Okay, it equals N of G and E divided by N of E. All right, on the top, let's see G and E. So for the G and E, like the previous example, G and E, that equals E and G. So E and G, G and E, they have only one element, is HH. Let's put 1 on the top. How many elements in E? We have 3. Let's put 3. And next one is P of G given J. Okay, rewrite this form into N of G and J divided by N of J. On the top, what is the N of G and J? G and J, let's highlight the common element. No, they don't have any common element. I'm going to put a 0 here because no common elements. So let's put 2 at the bottom because N of J has 2 elements. Okay, so 0 over 2, it is 0. Let's see, next example is P of F given J. And rewrite this one into the reduce the sample space method. The top is N of F and J divided by N of J. And F and J, let's see, F and J, so this element. And this element, what else? TH, TH, we have two elements. On the top we have 2, J has 2, well, it is 1. Okay, let's see, last one. P of J given F. J, sorry, N of J and F divided by N of F. So J and F. J, where's J? J and F. HT, HT, TH, TH. So on the top we have 2 elements. The F has 3, so the probability is 2 over 3. Okay, let's go back to the lecture notes. We solved all of these 6 probabilities. All right, let's complete the probability diagram. P of A equals 0.6. P of B equals 0.5. And P, A and B is 0.2. What is the meaning of A and B? That is a overlapped area. So here is 0.2. I know all of the A probability is 0.6. So this section is 0.6 minus 0.2 is 0.4. This is a section here, 0.4. And how about this section? I'm using the B probability, 0.5 minus 2. Minus 0.2 is 0.3. So this 0.4 is coming from the 0.6 minus P of A and B. And this 0.3 is coming from 0.5 P of B minus 0.2. Okay, how about this section? I'm going to use 1 minus 0.4 minus 0.2 minus 0.3. Okay, this section equals, so this section equals 1 minus 0.4 minus 0.2 minus 0.3. It equals 0.1. Okay, we almost found everything. You can also use the formula, which is 1 minus P of A or B. We have the same solution. Okay, let's see the first question. Find P of A given B. What is the meaning of P given B? P of A given B. So this is A, and this is B. And what is the formula? Some of you say, can I use the reduce the sample space method? No, because the given information, they are all probabilities. So let's use the probability, conditional probability formulas to solve this one. And I have learned the formula is P of A and B divided by P of B. What is P of A and B? Here, 0.2. It is 0.2 divided by P of B. 0.5 is 2 over 5. You can give me 2 over 5, or you just say 40%. Or I accept I accept 2 over 5. How about next one? Let's rewrite it into the formula form. P of B and A divided by P of A. So P of B and A, that is equals A and B, same thing. So P of A and B is 0.2. So the top is 0.2 divided by A, 0.6. It is 1/3. Okay, let's see next example. P of A given not B. Okay, this symbol means not B. So what is P of B prime? P of B prime equals 1 minus P of B. Okay, 1 minus P of B equals 1 minus 0.5. It is 0.5. Okay, rewrite this one. We are having we're having P of A and B prime divided by P of B prime. And let's see the picture. This is A, and this is B prime. Where is the overlapped section's probability? So which area has both blue and red? 0.4. So this section, let me highlight in green. This section has both blue and red. So we're going to put 0.4 on the top. And what is the P of B prime? 0.5. So we're having 4 over 5. That is 80%. Next example, rewrite it. We're having P of B prime and A over P of A. Okay, the last question we have solved, P of A and B prime. That is P of B prime and A, 0.4. Let's just copy it from the previous example. And the denominator is 0.6. So the probability is 1/3 or 4 over 6. And we can simplify it 1/3. All right, let's see next example. 2 cards are randomly drawn from a standard 52 deck in succession without replacement. Let's find the P of a second card is a heart. The first card is a heart. So the probability is not given. So I prefer to solve it by using the reduce the sample space. Okay, what is a reduced sample space? It is P of A given B equals P of A and B over P of B. Okay, so this question, P of second card is hard, given first card is hard, equals, let's make it short, P of second card is a heart, second card is a heart, and the first card is also a heart. Divided by, I said we are using the reduced sample space. So let's say n, and divided by n of. So first card is a heart. All right, let's see. The numbers. That's the second card is a heart, and first card is a heart. So for example, I'm going to choose the first card first. First card is a heart. How many hearts do we have? So we are having 13 hearts. So this is heart, and this is a diamond. This is a club, and this is a spade. So this is a spade. So totally, we are having 13 hearts, 13 diamonds, 13 club, 13 spade. So first card, for example, is a heart. I'm going to have 13 options. I'm going to choose 13 cards. Oh, sorry. I'm going to choose one card from 13 cards. I have 30 possible outcomes. All right. And how about my second card? My second card, I already chose one heart from the deck, the 52 cards. And then I only have 12 hearts left. And my second card is also a heart. I only have, 12 hard cards left. I'm going to choose second card is a heart. So choose one card from 12 hard cards. And the denominator, let's see. The first card is a heart. So I'm choosing my first card is a heart. So total you will have 13 hearts. And how about my second card? It doesn't matter because the bottom, I choose a card 2 times, or I choose 2 cards randomly. First time I choose a heart, and the second time it doesn't matter. I just choose one card from rest of the cards. So rest of the cards, I choose one already. So I have 51 left. And then let's reduce the fraction top and bottom. They are cancelled. So the probability is 12 over 51. If you don't understand, so repeat the video, or you ask me. Okay, the top and bottom, they are all divisible by 3. Divide by 3. Top we have 4. Divide by 3. The bottom we have 17. So solution is 17. Let's see next example. So here I said reduce the sample space, but I put the probability. Let's put the n here, n here. Don't confuse ourselves. Okay, let's see next example. P of second card is a heart. The first card is a club. Okay, if we are using reduce the sample space, n of second card is a heart. And the first card is a club. Divided by n of first card is a club. Okay, let's see this. So the top first card is a club. Let's choose a club from 13 cards. Okay, first draw, I'm going to have 13 different outcomes. And then second time, my second card is a heart. So I'm going to choose one card from 13 cards because that's a heart. So let's choose, let's put 13. Denominator, the first card is club. That means I have 13 clubs. I'm having 13 outcomes, possible outcomes. And then second card, I'm going to choose from 51 cards because I have 51 cards left. First card already chosen. So second card, it doesn't matter. It could be a heart, it could be a club or diamond, anything. Okay, reduce top and bottom. We are having 13 over 51. Okay, nothing can be reduced. Let's see next example. A survey of North Harris students has the following result. Okay, this question I'm going to use reduce the sample space because I don't have any probabilities here. I have numbers, all possible outcomes. So let's see. A student from a survey is selected. It's not like the previous one. Previous one we select 2 cards. Now we are selecting 1 card one student. So the question will be simpler. So rewrite this conditional probability into N of freshman and pepperoni divided by N of pepperoni. So let's see what is the N of freshman and pepperoni. We need to find the intersection area. So pepperoni, freshman, that's 25. So on the top, we are having 25. This means the student is a freshman, and also he chose the pepperoni. And the denominator is N of P. So N of pepperoni. So 55. It is here, 55. So let's put it down, 55. And do we have, can we do the cancellation, top and bottom? Oh, I copied something wrong. So I highlight the 25, but I put 21 here. Let's rewrite here. Okay, so the top and bottom, they are all divisible by 5. Divide by 5, divided by 5. So the probability is 5 over 11. Let's see, next example. P of pepperoni given freshman. So let's reduce the sample space. N of pepperoni and freshman divided by N of freshman. And N of P and F. Let's find where is the pepperoni and the freshman. 25. Again, 25. What is N of F? N of F. Freshman. The total number of freshmen is 45. Let's put 45 here. And top and bottom, they are all divisible by 5. Divide by 5, divide by 5. 5 over 9. Okay, let's see. Next example. Sophomore given sausage. So probability of a sophomore given the students selected sausage. Okay, that equals P of S and, let's say SO and SA, sausage. All divided by P of SA equals, what is P of sophomore and sausage? So the overlapped section. Sophomore and sausage, 20. Let's put 20 on the top. And P of sausage. So P of sausage is 35 divided by 35. They are all divisible by 5. Divided by 5. 4 divided by 5 is 7. 7 over 4. And next question is P of sausage given sophomore. So rewrite it. N of, my bad. This is N. Okay, N of sausage and sophomore and divided by N of sophomore. Okay, N of sausage and sophomore, we solved it in the previous step. They have the same number. We got 20 here. And the denominator is N of sophomore. N of sophomore is 55 here. So let's put 55. Top and bottom, they are all divisible by 5. 4 on the top. Bottom is 11.